Energy Leaders program. And I try in my research to combine between scientific research, technology breakthroughs, and the impact on this on economy, and later on policy design and investment decisions. So what I'm going to take you through today is how the climate negotiations would impact on future development of Saudi Arabia energy systems from the type of work that I'm doing at KAUST. So the research the presentation will look into the balance between the current climate goals and between the climate and the development goals in the kingdom, and the measures that have been taken to mitigate climate change in the Kingdom of Saudi Arabia over the past years, and what we think from the government perspective would be realistic for the kingdom and the GCC and the Middle Eastern countries to be realistic to be done in COP21 in Paris, and things that will be within the interest of our economy. And then I'll introduce you to what has been done at our institution to support the kingdom's transition to a low-carbon economy. Because our institution was one of the initiatives that has been built by the kingdom about 5 years ago in response to clean energy developments and the issues of climate and renewable energy developments. So as you all hear from the energy community, and you know that the components of an energy system would start from the resources, from the extraction of resources, the conversion, which plays a very key role in the utilization of the energy, and the fuel then that comes out within the conversion process, and how this fuel can be used, whether it's gas or liquid or electron, and then the distribution, the technologies, and the services. So the management of the energy system is crucial in the global transition. And the conversion aspects will play a key role, where the most scientific research is being focused in order to enable this transition to a low-carbon economy. Because from the conversion, we have the CO2. And from the conversion, we have the fuel and we have the electron. So the conversion aspects is a key element in scientific research and again in the transition issues. If we look into what the current profile of Saudi Arabia, how we are not a huge industrialized nation, we are a developing nation, but Saudi Arabia is, as you know, is the chief exporting of hydrocarbons, crude oil mainly, and the energy consumption of the kingdom is considered to be one of the largest oil consumer. So this is actually contributing very much to the CO2 emissions in the kingdom, not because of the industrialization, but because of the high level of oil consumption. And that's mainly because we are not rich in natural gas. We do not have all the technologies in terms of renewable, in terms of nuclear, to reduce the carbon footprint, but we use so many liquid hydrocarbons to generate electricity. And that's, according to the recent statistics from the Energy Information Administration in the United States, I can see this figure, which is less than other previous years. But according to the World Bank, Saudi Arabia is classified as the 11th, which is surprising to see Saudi Arabia having this high rank on the global CO2 and top CO2 emitters, exceeding industrialized countries like Italy, like France. And that means there is a serious issue that we need to really look at in order to make our CO2 emissions reasonable compared to other industrialized nations which emit less than what we do, and yet they consume more energy than what we consume. From WEC's recent trilemma report, we know that the kingdom is totally dependent on fuel for its electricity production. So we do not currently produce any electricity from non-hydrocarbon resources in the meantime at the state level. And again, the WEC assessment of the Saudi Arabia energy trilemma shows very useful figures. It shows that we score quite high on the security side, on the access, because we have enough power generation plants all across the kingdom to provide electricity access for across the whole kingdom. And that has been achieved within 50 years, because before 50 years, Saudi Arabia was just started. So within 50 years, we now have achieved a universal access to electricity within the whole kingdom of Saudi Arabia, and that's mainly because of the universal distribution of hydrocarbons to provide electricity for all rural and as well as the main cities within the kingdom. Yet our score on the environmental side is not high, and that's again because we did not implement any CO2 carbon capturing within the power generation sector, and again because all these power generations mainly use liquid hydrocarbons, not natural gas or nuclear or any low carbon energy technologies. So that's the recent WEC assessment, and we need to work very hard in order to improve the environmental impact, and that's what I'm going to explain later in the slides. So the balance between the climate policies and development policies. Saudi Arabia takes international initiatives very seriously. Experts from the kingdom take place and they participate in the IPCC report. And from the IPCC report, one of the recommendations is that the climate change effects, the procedures will slow down economic growth and make poverty eradication more difficult, and again, food security. I have heard wonderful initiatives from the past presentations on what the EU has managed to minimize the greenhouse emissions and make the economic growth high compared to other countries. But the infrastructures in the EU may not be available for developing countries. So learning from the experience of others is important in that. And that's what possibly we need to convey to policymakers in developing countries. So the current understanding of the kingdom is that the climate change negotiations and cutting CO2 emissions will have an economic burden, and we need to make it economic in order to implement low carbon transition. On the other hand, Saudi Arabia has taken many international initiatives. It has joined the Global Methane Initiative, the Carbon Sequestration Leadership Forum, which is very strategic for the kingdom because we have many oil wells spread around the kingdom, so these can be strategic to inject CO2 to enhance the oil recovery. So we are very much active in this forum through Saudi Aramco. And the initiative on building CO2 reduction into the major economies forum, that's another initiative where the kingdom is participating in order to explore better ways of reducing CO2 emissions. And again, the Kingdom of Saudi Arabia has formed an alliance with European countries that include Norway, Netherlands, and the UK in order to develop and demonstrate projects that shows a feasible demonstration of CO2 capture and sequestration, and to be economically feasible. Because especially with Norway, it's an oil exporting country. So the CO2 issue of capturing sequestration or enhanced oil recovery are of a key interest for these four kingdoms. Then Saudi Arabia has in the past years focused very much on energy efficiency. That's from stationary power generation and the transport sector. In the stationary power generation, the energy consumption in households and the industry is very much being raised in terms of enhancing its efficiency, and the measures to do that, not only by fuel subsidy or reconsidering the fuel subsidy, because electricity in the kingdom is subsidized compared to Europe or the US, but it's through the integration of good technologies like insulators, technologies like multi-distributed solar panels, trying to have the end consumer to enhance their consumption. And when we improve the end consumer behavior, then we can improve the policies so that we have a win-win situation where not only the government is acting, but also the end consumer itself. And we need to work very hard on that because the society in Saudi Arabia needs to be well educated about the sustainability of resources and the efficiency of consumption. That's on the stationary side, but it comes to the transport side. We have just implemented a fuel economy standard trying to improve the fuel consumption in the transport from 12 kilometers per liter up to 19 kilometers per liter. That's on the light duty vehicles. And that target is to be achieved by 2025. And this will significantly improve the CO2 emissions from the transport sector, it will reduce it, and it will also enhance the sustainability of the hydrocarbons and the consumption of hydrocarbon liquids in the transport sector. So these initiatives, which I have just described, were made by the National Committee or the Permanent National, the Center for Energy Efficiency, which is under the Ministry of Petroleum and Minerals, chaired by Prince Abdulaziz bin Salman, currently the Vice Minister of Petroleum and Mineral Resources. And again, this committee, which has just been transformed to a permanent national center, is working very closely with a national clean development mechanism, chaired again by the Prince, and they are working very much. And the clean development mechanism is essentially a national designation of what happened in Kyoto when the International Clean Development Mechanism was established to promote clean development across the world. So a subcategory of that international mechanism was established in the kingdom in order to promote and implement what takes place at the international level. And so the measures which I have just described can be summarized by first the major technologies that the kingdom is implementing is first CCS, carbon capture and storage, not currently at the permanent storage, but for enhanced oil recovery. Because that's what currently we need in Saudi Arabia. We need to add value. We need to make the capture of CO2 economical and add the value of any amount of CO2 captured and to improve on the economics of the oil fields. The efficiency, the energy efficiency we have just described, this is very critical and very important because it increases the lifetime of resources and it adds to reducing the carbon footprint of the kingdom from all energy generation sectors. The solar. On the solar side, and I will just talk more on that, and the kingdom is blessed with high solar intensity, especially on the eastern side and the central side. And solar thermal will form a key part to take a large share or a significant share within the future kingdom's energy mix. Currently, we do not have solar as within the current energy generation mix, but it will take place, I would say, by 2030, according to the plans being set by King Abdullah, City for Renewable and Atomic Energy. Then gasification, the switch from liquid hydrocarbons, not light liquids, the liquids that we cannot use to produce fuels. That includes those liquids that comes out from the vacuum distillation process, like heavy fuel oil that may be used to produce coke or asphaltene. Some of these liquids are economical to be gasified or turned into syngas. And from the syngas we can generate low carbon fuels. That includes methanol, dimethyl ether. We can continue the reaction to produce methane and other low carbon fuels. So the switch from heavy liquid fuels into gas is taking a key role at the Saudi Aramco refineries. And that's something we are very much engaged on at KAUST in terms of scientific research, because gasification technologies are not mature yet, but some part of it are mature and some part of it are very much under development. And one innovative thing is the underground gasification of hydrocarbons that can turn unextractable resources into hydrogen and syngas, and providing a very clean way of using hydrocarbons right from underground. And that's something that's why we are very much interested in gasification. Wind, forms another vector of the Saudi energy mix. And again, and most importantly, is R&D. We need to invest very much, and we're very much focusing on research and development, and not just importing technologies, but we also want to localize the R&D and produce the technology from inside the kingdom with international collaboration. And this is very important for the sustainability and the development of the local human resource, and the kingdom also economic diversification, and in a way that transforms from a resource-dependent country into a knowledge-based economic country. So the underground gasification, which I just described, that just shows you how it could happen, where we can ingest an oxygen and steam through the heavy hydrocarbon resources. A technology similar to this has been implemented in Canada, but not really towards production of hydrogen. It was towards the upgrading of fuel to produce light fuels by underground heavy upgrading and cracking of the oil. And one interesting thing is that it can produce ammonia, hydrogen, and other clean fuels. Other technologies that will be of a strategic interest for the kingdom and the GCC will be fuel cells, especially with direct carbon fuel cells that could use hydrocarbon fuel cells where we can generate the hydrogen on board without storing it, and then the hydrogen can be used to run a car, to produce station electricity. Generation 5 nuclear reactors that would include small and medium-sized reactors. And under the new, because now we have a new king, King Salman, we just signed an agreement with Korea, and with the recent president of South Korea, and an agreement has been signed between the kingdom and South Korea to build a new nuclear plant, which will be the first. So it will definitely make use of Generation 5 nuclear reactor, and it will be achieved within the next few years. So renewables, which I've just described, and multi-distributed renewable generation systems are of a key interest because they improve the security of supply instead of stationary power generation. Right. One thing which is the kingdom's currently now has done already, which is implementing a project to reduce CO2 emissions for CCS, for enhanced oil recovery. And it has reduced the emissions by 800,000 tons per year by 2015. So the project started about 5 years ago, and by 2015, its target is to reduce the emissions by 800,000 tons per year. And this project is already being done in the eastern side of Saudi Arabia, in an oil field called Al-Uthmaniyah. And although Saudi Arabia, if we talk about CO2 injection for enhanced oil recovery, is not really needed because we can just produce the hydrocarbons by natural pressure. But we started looking into this technology because we may need it in the next decades. And the success of this project would mean that a technology will be implemented when we need it to add an economic or improve the economics of the oil fields. Another initiative was made not just by the government or Saudi Aramco, but also the private sector. So a private company has made an initiative to buy CO2 and then convert CO2 into polymers or economic or products that can add value. And this is a very good, this shows that the policies being set by the kingdom could attract investments by the private sector, and they will play a key role in reducing the CO2 emissions of the kingdom, so that leaving it not only for the state, but also engaging private sector investments. And this graph here shows you how the process can be carried out, and this graph it just shows how the project can be carried out for CO2 injection for enhanced oil recovery. So the challenges, what have we benefited, what were the challenges? The first, the technology is suitable for achieving large-scale emissions reduction, as we all know, CO2 injection for enhanced oil recovery, and it has very good fit with industrial uses. However, the cost of technology can be high. So we need, if somebody or a company wants to invest in CCS for enhanced oil recovery, they need to have enough capital to invest in the technology and a sufficiently good rate of return. The environmental concerns, that's when it comes to thinking about, say, permanent storage of CO2. The scientific research has not been completed to a high maturity level about the long-term storage of CO2. So we need to work hard on looking into that, especially with the carbonate reservoirs available in the kingdom. The carbonate reservoir could react with CO2, causing the production of the acidic products out of the reaction between the carbonate and the CO2. And that's why we need scientific research in order to investigate how we can safely store CO2 underground. Issues of liability and arrangement, and that talks about the regulation. We need to have the right regulation being established. Of course, the climate negotiation, which still there's uncertainty what would happen in COP21 based on COP20. That will definitely have an impact on the success of such initiatives. And then the energy penalty associated with CO2, there's no penalty yet, although the Saudi government has recently made an initiative which is to have most of the energy-related companies in the kingdom to sign a binding agreement to limit their CO2 emissions, but without a penalty. On the other hand, they would lose the government support if they violate or they do not commit to the CO2 reduction levels that they have signed with the government. So that's the right penalty and carbon price needs to be established. Water requirements, we of course, because we depend on the sea, so we also have another problem with the water because we depend very much on the sea to produce water for fresh drinking, and that means we need to carefully trade or look into how this would impact and not to affect our water security for drinking purposes. So that will roughly the Saudi Arabian energy mix would look by 2032. I know in Europe you're already implementing renewables, nuclear that already happened, but in Saudi Arabia it's not yet, as I showed you in the first graph. But by 2032, that's the plan how it would take place. That's in terms of adding this into the oil and gas which is already in existence. So, and it will be 25 generation capacity from concentrated solar power. The PV would look like the generation capacity would be 16 gigawatt, and 17 from the nuclear, so something like 17 nuclear reactors distributed around the kingdom. Wind and geothermal, as well as waste to energy, and that waste here, that's not only municipal waste, but also include agricultural waste, that include palms, for example, where we have some waste that can be gasified to produce synfuels. But that will form some part of the mix. And the most important thing is that the CO2 emissions will be reduced by 60%, NOx by 75%, and the SO2 will be by 70%. So that's our ambition to be achieved by 2032. Of course, in response to climate negotiations and in order to have a fair share of the international efforts. And so then comes to what we are doing at the university level. KAUST was built to support this transition, because if you want to become a low-carbon country, that means you need to have the right talents in a place, and to have the people who would not only generate the research, but also run small and medium enterprises, the people who will participate in the implementation of projects, and we very much want to nationalize these talents. So at KAUST, the research that we do would feed very much into the conversion, and then the research output can be fed back into the society, and from back to the society to improve the research. And from that, we have 6 different research centers to achieve this goal. So the Membrane Research Center, that would look into how, for example, membrane reactors can generate hydrogen, separating the CO2 in a low-cost way. And then we have the Solar Research Center, which obviously would look into solar technology research. The Red Sea, because climate change not only affects our climate, but it also affects the marine life in the sea. For example, the CO2 emission, the acidity of oceans was 30% lower before industrial evolution compared to what it is now. And that will affect marine life, and we very much depend on the Red Sea for not only for trade, but it's also for drinking. It's a very strategic part. It's a very important resource in the kingdom. So Red Sea is definitely related to climate change as well. Water desalination and reuse, because with water you need energy. And without energy we cannot generate water in the kingdom. And we need to have sustainable source of energy in order to have enough water and to secure our water resource for the water that we need. Catalysis, and catalysis here means the reaction that takes place and how this reaction can be catalyzed in order to minimize the temperature, and when we minimize the temperature, we minimize cost. So catalysis is essentially the materials that can be used to improve the conversion of processes in a low-cost manner, and clean combustion, where I'm associated, where we look into the improvement of the engine and fuel design, and finally the desert agriculture, because if we can make in the desert, we can produce and plant, we can produce biofuels, which is currently not the case. And that's just some part of how refineries can be reconfigured in the future. So gasification and then synthesis gas, and then the clean fuels can be blending to produce gasoline and methane. So this is just one part of the reconfiguration of oil refineries, and the key question is, at what cost, at what CO2 emissions level, and resource capacity, what is the demand, and ultimately the impact of systematic configuration in existing refineries. So that's something we are very much looking at, and we're trying to improve the synergy between fuel makers and car automakers. So again in Paris, the King Salman was just here earlier 6 months ago, and the relations between France and the kingdom is very strategic in terms of energy resources. But we believe that the kingdom, with the reduction that must be achieved without undermining the economic growth, and the kingdom, even now under the new king, this policy will continue, because King Salman has just announced yesterday that one important factor within his reign will be diversification of the economy and not to make it very much dependent on fuel. So we will continue to have the same policies within the next decade. Proposed mechanism, and then the convention, and what we bear in mind, the developing countries. So we believe very much in that the development mode can do to help us. And then global cooperation opportunities, and then the closing remarks. And I thank you very much.
Thank you very much. It was very interesting to listen to you and to have a better understanding of Saudi Arabian climate policy. Thank you very much. The last